Greetings, it's the Digital Dog. Today I have a video tutorial that's going to cover the creation and use of DNG camera profiles in various RAW processors. So here's what I'm going to cover today. First of all, what are DNG camera profiles? How do they differ from ICC camera profiles? In other words, why would you even consider understanding the role of DNG or camera profiles in your RAW processing workflow? A big part of this presentation is going to uncover misconceptions about DNG camera profiles. And I was interested in putting this tutorial together after reading a number of forum posts from people who basically don't seem to understand what, why, and where DNG camera profiles should be used, when to be used, and so forth. So we'll cover that in some detail. Of course, I will show you how to build custom camera profiles and when to do so. And I'll talk about a very interesting functionality of DNG camera profiles called dual illuminant profiles. When do you want to use them and why would you want to build them? And then I'll show you examples of DNG camera profiles in Lightroom, in Adobe Camera Raw, and another third-party RAW developer that I'm quite fond of called Iridient Developer, which also supports DNG camera profiles. So before we go into Lightroom, Camera Raw, and so forth, we'll go through a few slides so that we're up to speed. Basically, what are DNG camera profiles? In some RAW processing converters, the DNG camera profiles are used basically to define the camera sensor, your specific camera sensor, and the effect of the illuminant that you're shooting under on that particular sensor. Now, I'm going to talk about this in detail in an upcoming slide, this idea of the illuminant behavior, because this isn't obvious in terms of when and where you need to build these particular profiles under what lighting conditions. So I'm going to go into some detail and discuss why it is necessary to build different DNG camera profiles based on the illuminant. DNG camera profiles are very conceptually similar to ICC camera profiles that are used in other RAW converters. The big difference is that DNG camera profiles are built to define or fingerprint the behavior of a camera much earlier in the processing stage than ICC camera profiles. ICC camera profiles, like other ICC profiles, are what are known as output referred, meaning you have to go and render the image that you've captured of the target. You have to decide how you want to control the various sliders and so forth in your RAW processing converter, and then you end up with some sort of a TIFF or PSD, what have you, that you then feed to this software to build an ICC profile. DNG camera profiles are quite different. They define how the camera and sensor and lighting are affected much earlier in the RAW processing stage. DNG camera profiles are known as scene referred. And basically what that means is they define a process that takes place much earlier in the RAW processing pipeline. I've used the term that they define a raw or data, and that is true compared to an ICC camera profile. Now I want to talk about some DNG camera profile misconceptions. There are quite a few out there in internet land, and they need to be dismissed. First of all, it's not necessary to convert your native RAW files to DNG to use a DNG camera profile. You will need to convert the image of the target that you capture, which has to be captured in a RAW format. That proprietary RAW file needs to be converted to a DNG to build that particular DNG camera profile. But thereafter, you can use these DNG camera profiles with your original camera RAW files from your camera. Now, if you do decide that you want to work in a DNG workflow, in other words, you want to convert your RAW files to DNG, one of the advantages is that the DNG camera profile, after it's selected, can be embedded inside the DNG container and travel with that data. The only time that you have to convert a camera RAW file to DNG is for the target that you capture for the DNG profile. You'll convert that particular target image into a DNG, build your DNG profile, and thereafter you can stick with a proprietary RAW file if you so desire. It's not necessary to build a lot of DNG camera profiles, certainly not for every capture. In most cases, 1 or 2 DNG profiles is all that you're going to need, and I'll talk about this in detail and show examples. Now, I know that marketing departments from companies that are selling solutions for DNG profiles would like you to believe that for $99, you're going to have to build lots of profiles all the time. The fact of the matter is, while the target that you purchase is very necessary for this production of a DNG profile, the $99 is very well spent. You won't have to build lots of DNG profiles, and you will see that the creation of a DNG custom profile for your particular camera will produce superior color results, and that is worth the price of admission. Now, some non-Adobe RAW converters do support DNG profiles. I'll show you an example in a RAW processor that I'm quite fond of called Iridient Developer. It fully supports DNG profiles and ICC profiles. So you don't have to lock yourself into an Adobe RAW workflow if you so desire to use DNG camera profiles. And as I mentioned, if you do use a DNG file, the DNG camera profile can be embedded into that container and travel with the raw data. Oh, and lastly, I should probably mention that DNG camera profiles can only be used with raw data. So if you've got a rendered image, a TIFF, or a PSD in Lightroom or Camera Raw, the DNG profiles will not be accessible. This is only for the processing of raw data. And down here, for those of you who want to know where DNG profiles reside on your particular machine, I have the paths for both Mac and Windows. So these are the locations where the profiles are saved and accessed by the various Camera Raw products. So what's needed to build these DNG camera profiles? Let's go over this quickly and then get into the meat and potatoes and show actual examples. You're going to need either a Macbeth 24 patch target or the newer X-Rite passport target. If you have either, you can build a DNG camera profile. If you have neither, my recommendation is to spend the $99 and get the X-Rite passport target. It has a lot of really useful functionality above and beyond the inclusion of this Macbeth 24 patch target in a mini form in a plastic case. It comes with other targets for white balancing and so forth. Go to X-Rite's webpage and check it out. But if you own a Macbeth 24 patch target, you can go to the X-Rite site and actually download their software, which is free, to build DNG camera profiles. So all you need is this target. You can also build DNG camera profiles using a free solution provided by Adobe Systems on Adobe Labs, and the URL is shown below. X-Rite's product can build DNG camera profiles from within Lightroom using a plugin. It also comes as a standalone software product, which I recommend because the Lightroom plugin cannot create dual Illuminant profiles. So I'll demo the X-Rite software, the standalone, in a minute. And this is how I generally build my DNG profiles because I find it much easier. It's very, very simple and easy to do. Additionally, Adobe has a DNG profile editor, which is also free. It's also on Adobe Labs. And you can use this for tweaking the DNG camera profiles if you so desire, for making special effects and so forth. It's a bit geeky, so I would say that it is absolutely not a requirement to check out this particular product, but if you find that DNG camera profiles are interesting and useful and you want to experiment further, you might want to look at this DNG profile editor. So, how many profiles do you need to make? Basically, you need a daylight profile, one shot in daylight. The conditions of daylight do not matter, as I'll illustrate in a minute. The white balance, the time of day, those conditions have no effect on the DNG camera profile. And again, I'm going to explain this in some detail. You're probably going to want to build one for tungsten if you're shooting under tungsten illuminant. And so those two profiles will probably cover a great majority of all of your shooting needs. You can also build what is called a dual illuminant profile, which contains both daylight and tungsten. And that's an interesting feature that we'll talk about in an upcoming part of the video. There are advantages and disadvantages to using a single profile for one illuminant versus a dual illuminant. But the bottom line is you'll probably need 2, perhaps 3 profiles. The exception would be if you're shooting under what I would call an odd illuminant. And again, I'll show you what I mean in a slide coming up. That would be, say, fluorescent, LED, metal halide, something that deviates quite differently in terms of its spectral response than a daylight or tungsten light source. And again, I'll explain this coming up. What matters is the wavelength of light, not the actual color temperature of the light. And to give you an idea, 5000K daylight is vastly different than a 5000K fluorescent tube. They may both have the same correlated color temperature value, but the illuminants are absolutely completely different. So again, what we're doing here is we are fingerprinting how your camera sensor responds to a particular illuminant. That's what we're profiling. We're not profiling the scene. We're not profiling the color temperature. White balance, which is a control that you can use in your raw processor, takes place much later in the raw processing pipeline than the application of the DNG camera profile. So I will illustrate that in an upcoming slide. I want to talk about illuminants, and then we're going to go into Lightroom and see the results and effects of these particular profiles built under different illuminants. Now, what I've done is I've used a really nice little product called Babel Color with my X-Rite i1 Pro spectrophotometer. I put the ambient head on, and I'm able to actually measure different illuminants. And what you're seeing here is the spectral plot of a tungsten bulb. And what is important here is not all of the little numbers and so forth. What you really need to do is pay attention to the shapes of these particular illuminants. So this is tungsten, and you can see how it sort of ramps up from the blue color wavelength into the redder color wavelengths. And let's compare that to a spectral plot of a Solex 4900 Kelvin bulb. You can see that the shape is quite different. One of the nice advantages of the Solex bulb, it's a daylight simulated bulb, does a very nice job. But again, it's quite different from this tungsten illuminant, as you can see here. Now here's a very strange spectral plot of a fluorescent bulb. This is actually a measurement in my 5000K, so-called 5000K GTI viewing booth, which uses fluorescent bulbs. And you can see that the shape here for this fluorescent is vastly different from the Solex bulb or the tungsten, especially in terms of the very spiky spectrum that you see throughout the plot here. And that's usually caused by mercury in those particular bulbs. This is going to play a profound effect on how your sensor in your camera is recording the color, and this is why we need to build a DNG camera profile for this particular illuminant. Now I want to show you 3 different daylight plots. We have overcast daylight, daylight taken at high noon in 7,000 feet in Santa Fe, and then very early morning daylight just after the sun has risen. And you can see how basically they have a very similar shape in terms of their illuminant. And this is why it is not necessary to create DNG camera profiles throughout the day. What you really need is just one DNG camera profile for a daylight scene. Probably the best thing to do would be to shoot one maybe at daylight, noontime. It will work just fine for an overcast daylight scene, an early morning daylight scene. But if you try to use those profiles for the fluorescent or vice versa, you're going to get less than ideal results. So what is important here is not the color of the light, it's not the time of day, it's not the atmospheric conditions and so forth. It's the actual spectral response in combination with your specific camera sensor that we are profiling. So what I'm going to do now is pop into Lightroom, and I'm going to pick an image that has a fair amount of different colors shot under daylight and go into the Develop module. Let's set this to fill. Let's just dismiss this altogether so we have a better view of the image. I'm going to come down here to the calibration pane area, and you can see here that the default for this particular setup on my version of Lightroom is to select the Adobe Standard Profile. And Adobe provides a number of different profiles for each camera system. So here's Adobe Standard. Here's Landscape. Let's just zoom in here a little bit more so that you can see the effect of toggling between Adobe Camera Landscape and Adobe Standard. And I think you can see, even though this video is probably not completely color managed running through the internet, but I think you can see that the color changes. You can try neutral and so forth. So now what we're going to do, let's compare Adobe Standard, which we see here, to some custom DNG camera profiles that I've built. So the first thing I'm going to do is I'm going to select my 5D Mark II, which is what captured this image, daylight noontime. Now, hopefully you can see the biggest difference occurred in the oranges and blues here. I'll go back one more time. Let's go back to Adobe Standard and then daylight at noontime. And as you can see, there's a slight difference because the sensor in my 5D Mark II is probably a bit different than the sensor in the 5D Mark II that Adobe used to build their particular profile. What we're doing here is we're trying to custom tune my camera sensor and my profile, and that is one of the advantages of a custom profile. Now, what we're going to do is now toggle to a target that was captured on an overcast day. I'm going to let go, and what you probably want to examine is the little boy who has the blue and orange outfit on. I'm going to toggle right now, and there's absolutely no difference on screen. So now what I'll do is show you the dual illuminant profile that I made, which uses both daylight and tungsten. And again, there's no visual difference on screen. And that's because what we are profiling is the responsive daylight on our particular sensor. So it really doesn't matter what time of day you shoot the particular daylight target. What matters is the illuminant that you're using. So for example, if I were to come here and pick tungsten instead of daylight, hopefully you can notice what's happening in terms of the blues and the orange, which makes sense if you can think back to the spectral plots that we saw, the difference between daylight and tungsten in terms of oranges and blues. Let's do this one more time. Here's tungsten, and here's the overcast daylight. And overall, there's a significant difference in color in these oranges, but you can also see it in the greens as well. Let's go back to tungsten. I visually prefer on my calibrated display the daylight profile. I'm not sure if you'll be able to see that or not, but as far as I'm concerned, the orange looks a lot cleaner. It doesn't have that sort of greenish cast. The blue pops a bit more. And so what we're seeing here is the effect of a custom profile on this particular scene. The target was shot thousands of miles away from this image, and the daylight conditions were different. The atmospheric conditions were different. None of this really matters. The idea here is that we are, again, profiling our sensor to this particular illuminant. So let's take another example so that you can see this up close. I'll do this very quickly. What I'm going to do is click on this particular image and zoom out. And once again, let's toggle between where we are at high noon, daylight overcast, no difference at all. Let's now look at the dual illuminant, no difference on screen. And lastly, tungsten. And that makes a significant visual difference. Now, the other urban legend that I've heard expressed is that, oh, well, maybe you need to make a DNG camera profile based on the ISO. So I'm going to toggle to a daylight profile once again. The camera that shot this particular target was set for ISO 100, as you can see here in the name. I'm going to toggle from Daylight ISO 100 to Daylight ISO 800, and there is absolutely no difference on screen. The ISO settings that you use to capture either the image itself or the target for the DNG profile have no bearing or effect on the creation of that particular profile. And let's again toggle to noon. There's no difference. But if we go again to, let's say, a fluorescent profile, there is a very slight difference. I'm not sure if you can see that, but there certainly is between tungsten, especially in the blues, and going back to the daylight profile, as you can see. So dual illuminant profiles, what do they bring to the party? Well, these profiles are built by loading two different camera targets, one shot under tungsten and one shot under daylight, into the software product. And basically, when you are using the white balance tool, the two profiles interpolate between those two particular tables. There's a table for Illuminant A, or tungsten, and daylight, D65. This is primarily useful when photographing in a mixed lighting condition, or where you might have a wider range of scenes that have different illuminants that are between those two particular types of daylight and tungsten. And again, this is a way of fingerprinting how our sensors respond to these mixed lighting conditions. In a lot of cases, you might want to just start off building a dual illuminant profile for daylight and tungsten, and that one dual illuminant profile may be all you need for 90% of the work that you do. So you can build a single illuminant profile for daylight and a single illuminant profile for tungsten, but you might also want to look into the idea of building a dual illuminant profile for situations where there's either mixed lighting, or you just want one profile that you can use in both conditions. And then when you're working with your white balance in your raw processor, the two tables that are in this particular profile will sort of tween between daylight and tungsten, depending on which direction you move the white balance tool. And again, all you have to do is capture two shots of the target under each illuminant and load them into the software, which I will illustrate right now. So what I've done here is I've launched the X-Rite Color Checker Passport software. It's very, very simple to use. What I'll do is I'm going to go and build a dual illuminant profile. The default is to open and select DNG, which would allow us to drag and drop our DNGs and build a single illuminant. The process for a dual is almost as simple. I'm going to click here under Dual Illuminant, and now you'll notice down here there are two little squares here indicating that we have two DNGs that we have to drag and drop. And here in the desktop, I have my target that I shot at noon, and I'm just going to drag and drop it in here. And what the software is going to do is it's going to, for lack of a better term, go into that DNG, build a little preview for us, and what's really cool is it's automatically going to find where all the little patches in my passport reside. And it did a very, very good job of centering them all. Even though the target is a little bit off-center and so on, it did an excellent job. You can, if you wish, move around these particular boxes, but most of the time, the product does an excellent job of finding the particular squares that need to be evaluated to build the profile. And up here you can see it says noon, daylight, noon, Macbeth. I've named these particular images already after conversion. And now I'm going to just drag and drop the tungsten DNG profile into the second square, or I could put it into the main image if I wanted to. It's going to do basically the same thing on this second target, which is shot hours and hours later in a different location, and you can see it has that sort of a warm tungsten look to it. You're not seeing any type of correction whatsoever in terms of what's shown on screen. And so I have my two targets here, and all I have to do is click on Create Profile. It automatically navigates to the right folder, and I just give it a name and hit Save. I won't do that because I've already created a particular profile. The other thing I want to show you is how smart this software is in terms of working with a target that is a bit overexposed. So what I'm going to do here is I'm going to go back to single DNG, and I'm going to drag and drop this target onto the software, and it's going to detect the squares once again and analyze the data. If I go in here and I say create profile, it's going to ask me to name the profile, and let's just call this test. Save. And as it goes about building the profile, it pops this dialog saying that the application has detected that one or more of the color channels are clipped and it cannot build a DNG camera profile. So if the target that you capture is underexposed or overexposed to the degree that the software feels it cannot produce a good profile, it will pop this dialog and you will have to go back and reshoot the target. So we're back in Lightroom, and what I wanted to do is let's click on a different image here. And you'll notice that in this particular case, it says Adobe Standard. And what if you would like the, let's say, daylight profile that you build to always be the default when you bring in images instead of that Adobe Standard? All you have to do is select that particular profile. And then while you're in Develop, if you hit the Alt or Option key, you'll notice that this button down here, Reset, toggles to Set Default. If you click on that, what you'll get is this particular dialog box, and you have the option to update to current settings. What you want to do is make sure that your current settings are such that you prefer them as they are, and then the only thing that you would change is the camera profile here. If you say update current settings, then Lightroom and Camera Raw will default to always using this instead of the Adobe Standard. Now there is one thing that I want to point out here. You'll notice that it says here, it knows that my camera is a 5D Mark II and it knows the serial number, but here it says ISO 100. If I go ahead and select update to current setting, only ISO 100 images will now take that new default. And the reason for that is if we go into our preferences in Lightroom, there is a checkbox here called Make Default Specific to Camera ISO. And it's a very useful feature to have, and I've talked about this in other videos. What I'm going to do is I'm going to turn that off temporarily, close that dialog box, go back here and say Set Default, and now you'll notice that only the camera and serial number show up. If I say update current settings, now every time I bring new images into Lightroom or in Camera Raw, this profile will be selected instead of Adobe Standard. Now that I've done that, I'm going to go back into my preferences and reset this, because there are cases where I'll build settings that I want to be specific to an ISO. For example, if I'm building a suite of presets for noise reduction. So there's a little bit of a tip there. Keep in mind that the DNG camera profiles that you build are camera specific and they're listed as such. So if you have more than one camera type, for example, like me, I have a 5D and a 5D Mark II, the profiles that I build for the 5D Mark II will only show up when I click on images that were shot with that particular camera. The camera on the left is a camera that has no custom DNG camera profiles built, and all you're seeing are the Adobe supplied camera profiles. The camera in the middle is from one of my 5Ds, and I built a custom profile called RTP5D test. And the reason I'm seeing that is because in Lightroom I've clicked on an image that was shot with that 5D. And on the far right I have the 5D Mark II, which we've been looking at in this tutorial, and you can see all of the custom profiles that I've built. So what's important to understand here is that if you have more than one camera, you're going to need to build multiple DNG camera profiles for each, and when you access them in the RAW converter, only the profiles for those cameras will show up. I've launched one of my favorite third-party, or I should say non-Adobe RAW converters called Iridient Developer, and it also supports DNG camera profiles, and I'll just very quickly show you that I can go in here and I can say load DNG camera profiles and navigate to my folder of DNG camera profiles, and again select one, hit OK, and it is applied in this particular raw converter. And the converter also supports standard ICC camera profiles as well. It gives you a choice. So the point here is that if you build a DNG camera profile for the Adobe RAW converter using the processes I've shown you, they can be used in any other RAW converter that supports DNG camera profiles like this fine converter. So for those of you using Adobe Camera Raw in Photoshop, all I have to do once I open a RAW file is click over on the little camera icon here, which takes me to the camera calibration pane, and you can see that the same options that I had in Lightroom are presented to me. So for example, I can now toggle to 5D daylight, and you should be able to see a significant difference between that and Adobe Standard. I can go back to ISO 100, ISO 800. Again, no change on screen because it plays no role. But as I said, you have access to your camera profiles both in Lightroom and in Adobe Camera Raw, and take your pick. They functionally provide the same options in both products. You can go back and forth from Camera Raw to Lightroom if you so desire. So we're approaching the 30-minute mark, and hopefully this video tutorial was useful for you. Hopefully it dismissed some of the misconceptions about DNG camera profiles. If you don't have a Macbeth color checker, I very much recommend that you purchase a Passport from X-Rite. It has a lot of other functions besides just building DNG camera profiles. You'll probably use that part of the target the least. It has very good targets for white balancing, which you may use more often. If you have any questions and comments, I'd love to hear them. Here's my webpage and my email address, and thank you very much.